Hi, everybody. Welcome to today's webinar, which is just 5 weeks to a higher ed data warehouse. My name is Brendan Aldrich. I'm the co-founder for Invoke Learning. We're hosting today's session. And as part of that, I did want to let you know that if you do have questions over the course of today's webinar, please feel free to use the chat feature. We'll be monitoring the chat feature. We may take some questions during the webinar as we go. Otherwise, we'll also be doing a Q&A session at the end of today's webinar to be able to answer questions that you may have. With that, I'd like to go ahead and introduce our host for today, Rick Smith from the Philadelphia College of Osteopathic Medicine. Rick, go ahead and take it away.
Sure. Thank you, Brendan. And first of all, thank you, Brendan, for allowing me to be here today and talk a little bit about our journey with a data warehouse here at PCOM. So good morning, everyone, or good afternoon, depending on where you're calling in from. My name is Rick Smith. I am the Chief Information Officer here at the Philadelphia College of Osteopathic Medicine. I joined PCOM back in February 2019, so just a little bit over 2.5 years ago. Even though I'm new to higher education, I'm not new to information technology. I've spent my entire career, 30 plus years, in various roles and capacities within information technology. Prior to joining PCOM, I spent 12 years at a very large National Health and Human Services organization as their VP of Information Technology. And as part of that, I spent, maybe 5 or 6 of the latter part of those years really on designing and implementing their data warehouse solution. So let me advance the screen here. So for folks who are not familiar with PCOM, we are one of the nation's oldest osteopathic medical schools, founded way back in 1899, dedicated to the education of students in medicine, health, and the behavioral sciences. The college is made up of really 4 schools. So there's the School of Osteopathic Medicine, School of Pharmacy, we have a School of Health Sciences, and we also have the School of Professional and Applied Psychology. The largest of those 4 schools is our Osteopathic Medicine. We have 3 campuses that make up the college. The campus that I'm reporting from today is in Philadelphia, right outside of Bala Cynwyd. We also have 2 campuses in Georgia, one in Sewanee, Georgia, which is about an hour, I believe, north of Atlanta. And we have a 3rd campus in Moultrie, Georgia, which is about an hour from the Florida border. We're not a large school, relatively speaking, to some of your schools. We service about 3,100 students across all 3 campuses, and we have about 700 faculty and staff, again, across all 3 campuses. So what I'd like to do today, before I really start talking about PCOM and how we came to find and begin working with Invoke Learning, I want to just take a few minutes to take you back to the beginning of our data warehouse journey. And I do this for really 2 reasons. One is I hope some of that, what I have to share, maybe help some of you on your journeys to build a data warehouse. Some of you may be in the same position where we are, where we don't have a data warehouse and we're looking to build from scratch. Some of you may have a data warehouse that may be decades old and maybe you're looking to upgrade. And then, of course, you may be somewhere in between. So I'm hoping that some of what I share today will be helpful. And number 2, if not, I hope you find it at least interesting. And if nothing else, you'll get an appreciation of why we're super, super excited to be working with Invoke Learning. So our journey really started back again in February of 2019 when I started. As part of my first 90 days, we spent time assessing our technology infrastructure, looking for really any challenges or opportunities. And amongst many things, one of the things that really jumped out is that PCOM was in need of some form of a data warehouse. So during that assessment, what we found is that we, most likely like every other college and university, have numerous enterprise applications represented by the few that I have listed on the screen here. While we have a lot of enterprise applications, these pretty much existed as siloed applications. So we had siloed information contained within each, some integration, but for the most part, it was really siloed information. And because these are operational systems, each one of these systems came with their own reporting capabilities, which from a day-to-day operational perspective worked just fine. We had no issues. Where things really became a challenge for us and started to break down is when we needed to start pulling data from multiple sources for our executive or strategic level reporting or analytics. So I'll give you an example. In our institutional research department, if a request came in for a dashboard of some sort that pulled data from 2 or 3 different sources, the institutional research group would have to go and secure a development resource. That development resource would have to go and understand the 2 or 3 different systems they were looking to pull data from. They'd have to understand the ERD diagram in the background, know how to access that data, and know how to pull that data. And then what they'd be required to do is to stitch that data together into an Excel spreadsheet and hand that back over to the IR group or whatever department was requesting it to build a report on top of that. Clearly, that's extremely inefficient, not very productive. And then, as you can imagine, from a data consistency perspective, it presented additional challenges, because if you ask that same request of a different developer and they pull it slightly differently, you're going to get different results. So the need for a data warehouse was very clear. It was actually articulated by a number of different departments, as part of the assessment. So when you take a look at the data sources and you start looking at all the enterprise applications that you may have in your environment, and this is a slide that represents some of the enterprise applications in our environment, but I'll tell you, it does not even include all of them. Nor do all these enterprise applications necessarily need to make it into a data warehouse, but many do. But if you start to think about, your executive level reporting or your strategic reporting that requires data from any one of these sources or more than one of these sources, the challenge becomes quite complicated, and it takes a developer weeks, to pull this data together for dashboards and reporting. So as a result of our 90-day assessment, amongst, again, other things, one of the things that we did is we put in a request for a project to actually begin evaluating, designing, and developing a data warehouse. Now, that project was initially slated to begin in early 2020, but the pandemic for all of us had different ideas. So our priorities changed just like everybody else's, and we wound up pushing the data warehouse project back until the end of December 2019, 2020, beginning of 2021. So when we officially did kick off this project, we had the stated goal of implementing a solution that would transform the way that we work. It would enable new ways for us to engage our current and prospective students, new ways to increase student enrollment, to improve our student retentions and graduation rates, and even to really boost the productivity of our staff and our faculty. So when we first started the data warehouse, we recognized that we would need to spend a lot of time, on our look back dashboards, building those descriptive dashboards that allowed us to look at things like enrollments and prospective students. But our real goal was really to move up this maturity level into the predictive and into the prescriptive areas, where we begin to use things like machine learning and artificial intelligence to provide us with some intel on how we can increase student engagement and the ultimate goal of improving student outcomes. So again, when we started this project, as I mentioned briefly, we did not have any sort of a data warehouse in place at all. We had no sort of a data lake, no central repository of data. So we were really starting greenfield from our data warehouse journey. Given that, we had 3 things that we really had to do. We had to really go out and evaluate and select a platform that was going to be the foundation for our data warehouse. Once we select a platform, we needed to select a model, and I listed 2 of the common models, the Kimball and the Inman models that you're probably all familiar with. Once we picked the model, we needed to then select the tools. What are the tools we're going to use for ELT or ETL, the extract, transform, load, or extract, load, transform. And then, of course, across all 3 of those dimensions, we needed to take into consideration our staff. Here at PCOM, we have 34 staff that make up IT. But because we don't have a data warehouse, a lot of these folks don't have experience with data warehouse design or build or maintenance or manageability. So we had to take into consideration what expertise we would need based on the tools and the platform and the model we selected. And then, of course, the capacity. And I'll tell you, from a capacity perspective, we didn't have folks available to really take the time to learn and to support this going forward. So when I started off this presentation, I talked very briefly about, and I mentioned that in my previous position, I did work on the design and the development of a data warehouse. Now, in that arena, we used the traditional data warehouse tools. So we were a Microsoft shop. We used a Microsoft stack of tools. So The back-end platform was Microsoft SQL Server. From an ETL perspective, we used SSIS for the extraction, the transformation, and the load of the data into the tables. And then we used the Kimball model. We used the dimensional fact table model to build out our data warehouse. It was an on-premise traditional data warehouse. And I'll tell you, it was in play for 6 or 7 years before I left, and it's still in play today. And from what I understand, it's still adding a lot of value. But what I did not want to do when I came here, and one of the knee-jerk reactions when I identified the need for a data warehouse here is, let's just pull forward some of the technologies that I'm familiar with, and let's start using the Microsoft stack of tools. Let's use SSIS. Let's use the Kimball model. But when I assembled the data warehouse team, which had representatives from IT and some folks from institutional research, when we started talking about it, we decided that we're going to hit the brakes a little bit. We're not going to jump into tools that some of us may or may not know. We're going to take a step back, and we're going to really look and think about what's out there. What are our alternatives? And that's exactly what we did. What we did as a group is we spent some time doing some research. We did some time talking with some internal folks, and a lot more time talking to some outside consultants and some expertise. Now, you see across the bottom of the slide here, we did talk about Oracle. We did talk to Oracle. We talked about SQL Server. These are platforms that have been in play for 30 plus years and have been very successful in a number of organizations, both in higher education and elsewhere. So we didn't discredit those. We did take a hard look at those. But as part of our research, one of the things that became pretty fascinating was that's a platform that really started to bubble to the top and get a lot of attention is what has been referred to as data warehouse as a service. And you'll see it up in the upper right-hand slide here. And you'll recognize some of the names under the data warehouse as a service. So you'll see things like Google's BigQuery, Microsoft Azure, Amazon or AWS Redshift. And then there's one that I didn't hear of at the time, but learned a lot about since, is Snowflake. So these platforms, these are the big four in my mind. Data warehouses as a service, they have a lot of things in common, but they do things that separate each other from one another. So we spend a lot of time vetting these different platforms. And I'm happy to say that after a period of time, we here at PCOM, we selected the Snowflake data warehouse as a service as our platform. And I don't want to take too much of a deep dive into Snowflake, but I do want to highlight a couple things about Snowflake that I think are important. And they're important because the features and the functionality really had an impact on our downstream decisions, specifically the model and the tools that we were going to select and use. So a couple of things about Snowflake. First of all, because it is a data warehouse as a service, gone are the days worrying about the Oracle and the SQL Server and the infrastructure it resides on. Of course, your hardware, your backups, your security, your protection, your availability, no longer our concern. That's the concern of Snowflake as a SaaS model, which is great. There's one thing that Snowflake did that I don't think the other platforms do, but I could be off on that, is Snowflake did a great job of separating compute from storage. And that was really important to us because that allowed us to scale against compute and storage independently, which will have a really big impact on cost going forward. It's a pay-as-you-go model. So initially, starting out with Snowflake, we had very little data and we were going to ramp up. But because it's a pay-as-you-go model, we were able to start with very little infusion of investment and then grow as we grow the data. Again, Snowflake, like the other platforms, they allow you to scale both up and out. So as we begin to pump more and more data in, more and more users, more and more models, this thing scales out infinitely with a click of a button, without any issues. One thing that is unique to Snowflake that nobody has that I'm aware of is they have what they call the data marketplace, which is pretty fascinating. So within the Snowflake platform and the data marketplace, there is a lot of publicly available data that you can access or get access to. But also through that data marketplace, you are able to actually share information with maybe other customers of Snowflake that you have a relationship with, if you're authorized to do so and provided the contractual information. It's a big differentiator between Snowflake and some of the other ones because we do take advantage of that. Snowflake also is interesting in that it's really what I'll call cloud agnostic, meaning the Snowflake platform really can sit on top of 3 different cloud providers. It can sit on top of Google Cloud, it can sit on top of AWS, and it can sit on top of Azure. We chose AWS as our cloud provider to put Snowflake on top of, and we were actually able to move out of that if for some reason we weren't happy, but we were incredibly happy. So we have no plans on moving off of AWS. There's one other feature that is part of Snowflake that is also common with the other data warehouse as a service providers, and that's something that I was not aware of going into this research, but became familiar with, which is the columnar architecture of these data warehouse as a service platforms. The columnar architecture is different from the row-based storage that we're all used to with traditional databases. So your traditional SQL Server and Oracle databases all store data in rows when they're storing that information on your drives within the blocks. From an OLAP perspective, these systems store information in columnar format, and that's really important because the way they store data really allows us to store very large amounts of data and to query that data without any performance hits. I'll talk more about that a little bit later. But the key feature is the columnar architecture, the separation of storage from compute, and the ability to scale out, and the data market really did one thing that was which is pretty key, which it provided us with an alternative to the traditional dimensional models to consider. So we chose the platform. Platform was Snowflake, but because of the capabilities that I just described, we now had another very attractive alternative to consider. So on the left-hand side, we were still thinking about, the dimensional model, but because we're able to take advantage of the cheap storage space, and because we're able to get the performance values out of the columnar architecture, we had another choice called what we're calling denormalized large wide tables. But what that really did is left us with a really big second decision, which is, we have our platform, we chose Snowflake, we know what Snowflake can do, but we still had to decide, do we go with the traditional dimensional models, the Kimball, the Inmon, or do we ditch the star schemas, the dimensional models, and go with the very large, big, denormalized wide tables? So as the CIO here at PCOM, there are 3 things that I'm primarily concerned with. One is time, the second is cost, and the third is value, and really time to value, that last one. But there were some other things that we needed to consider before we made a decision about which data model to go forward with. So things like performance, how is it going to perform using large wide tables versus dimensional models? Understandability, which is easier for the business to understand, a large table or a dimensional model with some joins. How quick can we build these tables or dimensional models on a daily basis when we're refactoring or rebuilding our data warehouse? And then, of course, speed of implementation, time to value, very important. We also had to take into consideration our future reporting needs. Again, not just the descriptive reporting. We know we're going to build descriptive reports for our look-back capabilities, but we really want to build a solution that is going to allow us to look forward from an artificial intelligence perspective so that we can really have an impact on student outcomes. And then again, which one of these models is going to allow us to, be a little bit more agile and easier to maintain? So again, the data warehouse team that consisted of a number of analysts from the IT side, the institutional research group, a lot of conversation internally, but again, even more conversation with some experts out in the field. So we consulted with a number of different experts, and what we decided is that we are going to ditch the Kimball star schemas, the dimensional models, and we're going to go forward with these very large, wide, denormalized tables. The platform we selected was perfect for this platform, for this type of a model. Again, the data storage was so cheap and compression techniques so much better, we could pump so much data into Snowflake and not be worried about cost. If you think about the Kimball model, and even the Inmon model, when they came out, decades ago, they were really designed to tackle those things, the cost of storage and performance. The Snowflake platform and these others really solve that problem. So from a cost perspective, and then again, from a performance perspective, no longer an issue. In fact, there was a study done by a vendor called Fivetran. They are an ELT or ETL type of a vendor, but they actually did a bit of a study against Snowflake, BigQuery, and Redshift. And what they found is that they got 25 to 50% quicker, better performance against large wide tables than the traditional star schemas. So there was another validation that, we're making the right selection moving forward. And then again, if you just think about, a very deep and a very large wide table. And when I say large wide table, we're talking in the hundreds and hundreds of columns these tables can have. From a business perspective, and even from an analyst perspective, it was much easier to understand the data in that one large wide table than looking at the fact tables and the dimension tables and figuring out how they relate and they join. It's doable. We've been doing it for 30 years, but the flat tables made it just a little bit easier and simpler to understand and then, of course, to maintain. So then now we have a platform that we chose, which is Snowflake. And then after a bunch of research and conversations and consulting, I was very pleased that we landed on a data model that we were going to implement in the form of large wide tables. But we still had the third leg of the stool that we needed to pick, which is critically important, which is, okay, we have our platform, we have our model. How are we going to get our data extracted, loaded, and transformed into those large flat tables? So again, we did some research, and we started off with a sizable list of ETL vendors. And over time, we narrowed that list down to 2 that we were very interested in. We contacted both of those vendors, and both of those vendors were fantastic, and they offered each to do a 90-day proof of concept pilot where we would actually implement their tools, learn enough about their tools so that we can start pulling data out of our source systems and into Snowflake and then transform them into some flat tables. At the conclusion of the pilot, when we were, if we move forward with the proof of concept pilots, then at the end of the pilots, what we'd be left with is making a selection of which product we're going to go forward with and then begin implementation. And in conversations with the vendor, what that looked like is that after the 90 days, there's a pretty steep learning curve for both of these tools. So I'd have to identify some folks on my staff or go out and hire someone to come in and learn these tools, which again, there's a steep learning curve. So it's going to take weeks or a minimum of several weeks to learn the tool. And then we would have to kind of design and begin developing or coding the ETL processes to take that data from our source and transform it. So all that wrapped up with a 90-day proof of concept pilot plus the time to learn and implement. But we were looking at about 6 to 9 months before we saw our first real component of the data warehouse that we can start reporting against. So that was of primary concern to me for a couple of reasons. Number one is again, from a staffing perspective, I don't have folks that I could have pulled from my existing team to kind of learn these technologies and get up to speed. And it would take me time to hire for sure. And then number two, even if we found that person pretty quick, we're looking at 9 months before I actually get any value out of this. And I was looking for a much, much quicker turnaround. And that is when I'm very, very happy to report we met Brendan and the folks from Invoke Learning. So Brendan, if you don't mind, if I could turn it back to you just for a minute or two to talk a little bit about Invoke and what you have to offer.
Absolutely. Well, we have one quick question that came in. There was a question in regards to data cleansing and whether you're doing data cleansing prior to going into those large wide tables, after they're in the large wide tables. What is the approach that you're taking when it comes to cleaning data?
Yeah, great question. So I learned this at my previous position when we start first building a data warehouse, and we're going through it again here today. What the path that we took is that we chose to allow the data to flow into our data lake, which you'll talk about in a few minutes, but the data to flow directly into our data lake and to be flattened out into these large collections. Once they landed in these collections, what we built is a dashboard right on top of that. It's what's called our quality scorecard to start looking at those data anomalies. Because the first year in my mind, and when you're building a data warehouse, regardless of the tools, is the first real value you get out of the data warehouse is going to show you all your warts. It's going to show you where you have some data issues in your source systems. So what we've been doing is letting the data flow into the data collections, running our data quality reports, and then working with the business to go back and fix that data in the source, and then let it flow back into the data warehouse.
Perfect. All right, well, why don't I go ahead and take over just for about 3 or 4 slides just to talk a little bit about what we're doing at Invoke Learning. And Rick, then I'll turn it back over to you to continue the story of the journey with PCOM.
Sure.
So with Invoke Learning, both my partner Lige Hensley and I, before founding the company, had spent about a decade working for some of the largest city and statewide college and university systems in the country. And through that, had really spent a lot of time with data and with the needs of the institution and the various constituencies. So in founding Invoke Learning, we started, as you see on the chart here, with our Invoke Data Lake, which is a way we're very quickly able to bring data together from not just campus data sources and hosted data sources, but a variety of publicly available curated data sets that we can use to enrich that data and then surface it in a very quick, immediately queryable format. Now, on top of that, we have a variety of other products that we've layered on, which leverage the other thing that we've done at Invoke Learning, which is develop what we call an education-focused AI for analytics. It really is able to very quickly dive through all of these data sets that we're making available to it and help to have our IT and our analyst and research teams focus in on those areas that are critically important to these momentum points along the student journey. So Rick, if we can go on to the next slide. Starting with the Invoke Data Lake. And as I mentioned, we're bringing a lot of data here. And when we talk about very quickly, Rick's going to talk about how fast we did some of that work for PCOM. But being able to really get something like this together and launch so that you're not spending 6 months, 9 months, or a year building your data warehouses, but really in a matter of weeks, being able to get up and running and start to get into those analytics much more quickly. We do external security audits. I know a lot of folks are very concerned, as we were when we were working in our institutions, about the safety and security of the data. So we do quarterly external reviews and audits of our protocols and compliance. And that's to ensure that there will never be any sort of issues with the data. And again, one of the things that I think Rick will hit on a little bit more is just that we've designed this to be what we always hoped that somebody would approach us with. A very capable, very flexible platform that's a very low lift on behalf of the colleges to be able to get up and running, and something that you can begin to capitalize on very quickly. Okay, we'll go on to the next. Here, just a quick view at the overall Invoke Learning architecture. You're just seeing a lot of things coming in from the left-hand side. And really, that Invoke Data Lake forms the core of what we're doing. And then around that, we're wrapping some pretty cutting-edge technology, a deep understanding of education that came from our own experience working at our institutions and systems, and then very much focused on speed to insight in order to deliver value through that data and through those applications that we then surface on top of that as well. And I think Rick also mentioned Snowflake, and that'll be on the next slide. One of the things that Snowflake really helps us do is that secure sharing of all that publicly available data. You know, with a traditional data environment, you're used to not only bringing the data sets in that you want to use from all these different agencies, but having to replicate that data into each environment where it needs to be used. And here we're actually bringing all that data in once, and Snowflake allows us to securely share that with each of our college clients to be able to enrich their existing data and provide a lot more value. Okay, and I think, do we have one more? Nope, I'm going to go ahead and turn it back over to you, Rick.
So thank you, Brendan. So I want to take you just very briefly back right before we met Invoke and before we had our first conversation. If you recall, as I just presented, we spent a considerable amount of time thinking about the platform, and we did choose that. We chose Snowflake, which we're pretty excited about. Even before meeting the folks from Invoke, we selected a model, which is the large wide tables for all the reasons I described. And we're now in a position where we're thinking about the tools. And again, you know, one of the concerns was, you know, we really did not want to have to go out and hire folks and then really wait 9 months to maybe a year to start seeing any value out of this. So when Invoke came along and we jumped on a call, and I went with Brendan and Lige and some other folks, and they laid out what they had and what their capabilities are, I'll be honest with you, I was a little skeptical in the beginning, just truly, because what they were offering is to do what I was trying to do, what we were trying to do here at PCOM in a fraction of the time with little to no resources of my own. You know, so I was a little skeptical, but I will tell you, fast forward a few months, and Invoke Learning has checked all the boxes and then some. So again, they were able to, again, using this, they're built on top of the Snowflake Cloud Platform, which is a check, because that's probably how we came to meet the folks with Invoke, because we were both Snowflake customers. But again, their solution provided for those large wide tables, and I'll talk more about that in a few minutes. The speed to implementation, as I talked about, the time to value is hugely important to me as the CIO here. And I'm going to talk about the speed to implementation on the next slide. That was a key element. But as Brendan mentioned, once data start flowing into the data lake and the data warehouse, that data became immediately available for querying to start generating ideas and questions and feeding some of our other tools. One of the things that Invoke had and offers that I was not even thinking about, but is a major benefit to us, is this next bullet called where it says provides historic stability of source data. So again, we have numerous enterprise applications like all you do, and a lot of our systems do not track history. They might track some history, but not all systems track history, and not all tables within the same system track history. But by the nature of the way Invoke loads some of our raw data out of, say, Banner into the data lake, they do that. They do full loads on a daily basis every day, and by virtue, they are tracking changes of all of our source system over time, which is a major benefit that I wasn't even thinking about. And we'll talk more about that in a slide that's coming up. Both Brendan and I talked a little bit about the publicly available data that's available in the marketplace, and that data is being used to enrich our collections. I'll talk about that again. In addition to the source data that I just talked about, when the data is flattened out into what we call in the large wide tables, or what Invoke calls collections, there's also tracking over time within the collections itself. So if you think about type 1 or type 2, slowly changing dimensions that you might be familiar with dimensional models, the way that Invoke loads data on a daily basis, full loads into Snowflake, we're tracking all those changes over time. So we can report on trends as data changes over time from the collections and also from the source of the data. And again, the big thing for us is that the data that gets populated into these collections has to be made available for a variety of different uses. For our business intelligence tools, we actually have two that we're gonna go down to one, but we use Tableau, we use ClickView. We use Argos here for our operational reports that can snap right on top of the data warehouse. Our institutional research also uses SPSS to do some advanced analytics and some other models. So again, Invoke, really when they became the third option of the tools that we're looking at, really knocked it out of the house for us, because they checked all the boxes and then some.
And as you mentioned, Rick, it was one of those where, we had always found it was so tough from a research standpoint to be able to realize that you needed to trend a value and to not have that trending enabled, so that by the time you enabled it in a traditional data warehouse, you could spend months waiting to gather enough data that you could begin your trending, and a year before you could do year-over-year analytics. So that was part of the approach that we use that you just talked about, and making sure that literally every data element we're tracking becomes a trended, what you would think of as a traditional type 2 slowly changing dimension.
Awesome. So I want to pivot a little bit and talk a little bit about the experience over the past several months that we've had with Invoke. So when I talked about speed to implementation or time to value, and again, I was looking up a mountain of 6 months to 9 months to implement. When we started off with Invoke, literally from the time we signed the contract until the data start really flowing into our data warehouse, these collections, it was literally up and running in 5 weeks. Now, it doesn't mean we were done. We had a lot of work to do, but the data was flowing into the data warehouse, queryable by our analysts and our institutional research team in 5 weeks. And most importantly, all the heavy lifting was done by Invoke. We had a couple analysts involved in it because we had to talk about, some of the customizations that we've done within our systems. But the whole ELT process, the whole ingestion of data from our source systems into the data lake, into the collections, was 100% done by Invoke, which really took care of my staffing concerns about, either hiring some additional staff or pulling staff off of projects to learn a new tool. Very minimal reliance on existing staff, which is huge. Now, when we started off, we had the option of pulling data from multiple sources into these flat, large, wide tables called collections. Here at PCOM, we chose to start off with two primary systems. We're an Ellucian banner shop, and we're a Blackboard shop. And of course, we have many, many, many other applications, but we wanted to start off with these two platforms, at least initially. And we started off with identifying 551 tables to pull from those two systems into the data lake and in those data collections. And another major benefit, at least from our perspective, is that the folks from Invoke have a very deep understanding of these two platforms and others. So it wasn't us telling them which tables we want to pull. They were telling us which tables to pull, which is fantastic. Starting with these two platforms, again, we wound up building three large wide tables of collections, and you can see them on the screen here. One called course section term, one called student credential term, and one called student course term. And if you look to the right of each one of those collections, you'll see the current number of fields that make up each one of those tables, and they're going to grow. So this is our starting point, these two systems, but we are going to add data to these systems. So these column counts are going to go much, much larger. Again, these three collections, not only were they take data from these 551 tables and flatten them out into these three collections, but at the same time, they added that publicly available socioeconomic data that I talked about earlier. So if you look at some of the data in our collections, you'll see information on median incomes, on opioid use, on unemployment rates in certain areas. And Brendan, I think you'll probably show some of that a little bit later. We had immediate access to a very powerful yet simplified data architecture, and that was huge for us. And again, our institutional research, they've been asking for this for years prior to me even coming here, to be able to access this data and understand this data, most importantly, themselves without having to go through IT, without having to go through a developer.
But the other thing I wanted to mention is that from the Invoke architecture, it's designed in such a way to be able to give colleges a jump start into a modern data architecture. So one of the things that we haven't really talked about is we talk about Snowflake, but the fact that PCOM has their own Snowflake account where all of this is shared as one unified architecture, so that as Rick's team really comes more deeply up to speed on Snowflake and the capabilities of Snowflake, Rick, you really and your team have the ability to onboard new data sources, design new data structures, to really take ownership of that environment as you go, as opposed to having to run everything through Invoke Learning in perpetuity.
Yep, absolutely. So I started off a number of slides ago talking about, some key success factors when we're making our decision. So when you go back to the beginning of the project, we were looking at, do we go with traditional data warehousing? Do we look at the cloud-based technologies, data warehouse as a service, and what are the tools? And in summary, if you take a look at this slide, this is kind of where we landed after a number of months. From a traditional data warehousing perspective, although they've been in play for 30 plus years, I think the time has come, in my opinion. Time is high and cost to implement is extremely high. Time to value extremely low for traditional data warehousing. When you start looking at data warehouse as a service, whether it be Snowflake or BigQuery or Microsoft Azure, a lot of that heavy lifting with the infrastructure and the backups and the retention, the security models kind of goes away. The cost goes down. You're not procuring your own servers and staff to support the infrastructure. So cost kind of levels out a little bit and gets a little bit better than the traditional data warehousing. Time to implement certainly goes down again because you're not worrying about the infrastructure. That's somebody else's to worry about. So the time to value, even after looking at Snowflake and the large wide tables, was starting to look very attractive to us. But the aha moment for us really is when we met Invoke, because again, with the Invoke, the time to value was far better than any other tool that we've looked at or tried to vet, prior to that. So time, as I mentioned, 5 weeks versus 6 to 9 months to get something up and running and queryable was just something beyond what we even dreamed of. Cost, very, very manageable, and I'll let Brendan talk the cost of the Invoke solution a little bit later. And again, time to value. Never did I think we'd be able to implement some of these technologies in a few short months, let alone the first year. So with that, Brendan, if you don't mind, I'd like to maybe turn it back over to you to maybe do a little bit of demo of the Invoke Data Lake.
Yeah, absolutely. In fact, you've talked about the large wide table design, and that's one of the things I wanted to share on my screen here as we get started, is this is one of our collections. It goes down to the granularity of student and covers students and courses and grades and terms that they're enrolled. And you'll see the data date here at the top. That's because we're loading all of history every single day. That's how we're creating that slowly changing dimension across all of the data elements included here. As we take a look at what's included, though, you're going to see data from a variety of different data sources. And this is just a demo environment, but you're going to see a lot of student information system type data starting off with. And as we scroll down, we'll get into some learning management system activity, including some data we enrich and add. So in this case, we're actually generating columns that are tracking the amount of time spent by each student during each hour of the day within the learning management system. Which provides some really interesting analytic capabilities. But you'll see other data from the learning management system in regards to quizzes and assignments. We're getting into some of the NOAA data. Some of the analysis that we're doing on the relationship of weather to student engagement is really relatively fascinating, but we're seeing a bunch of weather data here, including precipitation. And we get into other public data sets from the Bureau of Labor Statistics and the National Institute of Health. So you're going to see violent crime rates, you're going to see SNAP participation, household income, uninsurance rates, opioid death rates. All of these are taken from the public data sets, and when they're joined into this collection are made relevant to the location of where the student lives, so that we can do some really intriguing analysis that really previously wasn't easily possible. And this goes on and on. I think we've got a couple of hundred tables in here, but let me show you one of the benefits of this is that when you run a query against it, since all of those complex dimensions have been what we call degenerated back into the primary fact table, you have no joins. And I know in running some of the institutional research teams that I've been responsible for, literally that's one of the more frequent areas where you can unintentionally make a mistake would be an incorrect join or an incorrect type of join between two different tables. So in here, I'm just going to bring up, this is the same data set we were just looking at, a student term course. And if I do a quick query here, you can see in my demo data set, we're looking at about almost 59 million rows of data. So with that, I can go back and do a really more complex query, such as this one, where I'm going to go ahead and kick this off. And what I'm doing is I'm looking for a count of students by ethnicity from a given term on a given date that live in neighborhoods with slightly elevated levels of unemployment and poverty and do at least some percentage of their work in the learning management system after 8 p.m. at night. And you can see that result came back here in about 2 seconds. This is the type of thing that even if we had that public data available, we'd be joining to a variety of manually loaded data sets and really having to ensure the integrity of both our query and the quality of the way that the data had tied back in, which is all being done automatically every day. So just an example here where we've eliminated that need to join and really empowered colleges with the ability to do a much more complex analysis across all of this public data, included with their own data, to really deepen their understanding of each student and what their needs are to help support them as they move on their way towards graduation. So with that, let me just, that was just a quick demo, but Rick, let me go ahead and pass it back over to you. I'll stop sharing.
Sure, share my screen. Yep. All right, so thank you for that, Brendan. So only a few slides left. So here we are in October, and what I'm happy to report is that from a phase 1 perspective of our data warehouse journey, we have accomplished what we set out to do, which is really to identify, design, and implement a data architecture that is going to allow us to transform the way we work to really have an impact on our students and our faculty and our staff. So the diagram you're taking a look at on your screen here it's a very simple diagram, but it really does reflect just how simple the architecture is that we've implemented with the Invoke solution. So again, on the left-hand side, you just have a sample of a couple sources. And I will point out that I did mention we started off with Banner and Blackboard, but we are soon going to be implementing data from our Slate system, from a couple other systems, eValue, which is a clinical assessment system that we use here at PCOM. We're also considering implementing data from Zoom, so we can look at Zoom usage for some of our online or hybrid classes that we're doing. So we're still vetting which sources we want to pull in which order, but regardless, all that data gets ingested through Invoke without any heavy lifting from us or our staff. It gets ingested by Invoke into our data lake. And again, it's all those raw tables. That's where that 551 tables exist. And again, it's got the historic data from the source systems being preserved in there, which is awesome. And that data lake, even though we're using that data to kind of transform into the data warehouse, that data lake information is available to analysts and the IR group and other folks who want to query directly against the data lake, which is an added value. But once the data lands in the data lake, the next step is to go what we're calling the ELO. So it's the extract, it's the load, it's the organize and supplement. So this is where we're taking data from those 551 tables, we're organizing that data, and then we're supplementing it with the publicly available data that Brendan just talked about, and flattening it into what we're calling the data warehouse, which is those 3 collections. And again, those 3 collections are pretty wide tables right now, but they're only going to get wider as we add some additional sources. And then the last piece, which is really pretty exciting, is now it becomes pretty easy. We have the 3 collections, and now what we're going to do is we are going to layer some very purposely built views on top of those collections that represent our data marks. So for example, we built a view called Census Headcount Enrollment, which is a very specific view that's going to be pulling certain data out of the collection and handing that off to our institutional research team. Our institutional research team can pull from those views directly as data marks, so they don't have to try to figure out where the data is themselves. We made it even easier for them. But they also have the option of going back to the collections if they want to do some of their own data pulls and analysis. And they also have the option to go all the way back to the data lake if they want to do some additional query. So again, a very simple but very powerful architecture that we implemented using the Invoke solution. So we're very excited about where we landed. Our institutional research group is beyond excited. If they were on the call, they would probably share that with you. They've been using Tableau for the past 2-3 years. But as I mentioned at the very beginning, they've been using Tableau and layered that on top of maybe Excel spreadsheets or other data that's been extracted and stitched together. They now have the ability, with using this very powerful business intelligence tool, to connect directly to Snowflake, directly to those views or directly to those connections, pull that data in, and they can begin building charts and slicing and dicing any way they want without any involvement from ITS, any involvement from any developers. So they're over the moon excited about using Tableau the way it was designed to be used, using Snowflake, using Invoke, using our collections, using Tableau. So really quickly, this is the last slide. I just want to kind of share where we are today and where we're going. So the question was asked earlier about data cleansing. So as I mentioned briefly, our first pass is to let the data flow into the collections as is, and do some data cleansing that are identified as part of that data landing in the collections. So that's great for the first several months until we get the source data kind of cleaned up in the system and start flowing in again. But once we start adding data and cleansing the data, how do we keep it clean? How do we know it's clean? So what we don't want to do is allow, once we cleanse it to the point where I think we're in pretty decent shape, we don't want to have to keep running those quality dashboards and looking at bad data in the collection. So we are using a separate tool here that's going to monitor that data as it flows into the collection. So we can set up quality rules using this other tool that'll say that, if this particular field has to be between certain values, or where it can't be null and it's not a required field, flag it. So we have other mechanisms to flag that data as it's hitting these collections, so that we can quickly go back to our data governance group and say, hey, we got some bad data coming in, make sure we go back and clean that up a little bit. So we're pretty excited about that opportunity. I mentioned earlier that we are in the process of identifying some additional data sources that we're going to add. Slate, again, is our CRM system being used by our admissions department. That is most certainly going to be one of our next sources that we load. We also do a lot of simulation labs here at PCOM, so some of our simulation data is going to be added. We're going to look at adding some of our Blackboard Collaborate data and Zoom data, so we can start taking a look at, students and, engagement, with Zoom and other video conferencing capabilities. So we're excited to get some additional data on top of what we already have. And then again, institutional research, now that they have access to this data, They're first starting with those descriptive dashboards, that look back data, so we can start building enrollment dashboards, admissions dashboards, graduation dashboards, and whatnot. But our ultimate goal, like I mentioned in the very beginning, is this last bullet, which is to really start looking at some of the artificial intelligence that are going to help us to figure out, how are students engaging and how do we improve student outcomes. And the one thing I'm very excited to say, that by the end of this week or next week, we are going to be turning on our first artificial intelligence model, the Invoke engagement model, with the help of Brendan and his team. So if you asked me at the beginning of this project back in early 2021, the end of 2020, would I be talking about turning on an artificial intelligence model in this fiscal year? Not even close. My hope was just to have data model number 1 developed by the end of the year, and we far surpassed our expectations. So we're very, very excited. So with that, I think we're at the point where we have time left for some questions, Brendan.
Perfect. So everybody, if you do have questions, feel free to share them into the chat. And for those who I know sometimes you have them, the folks that don't like the Q&A sessions and you're going to drop off, contact information for both Rick and I is listed on your screen. If you do come up with questions or you'd like to follow up on a specific area, you can certainly use that information to reach out to either one of us in order to answer those questions for you. Rick, so one of the questions that's come in is related to the architecture, and that you've talked about the systems that you brought in already, the systems that you've planned next. Really, what kind of penetration do you really hope to achieve in terms of bringing data from those applications into the Invoke data lake with PCOM?
Sure, good question. So we started off really with our largest system, the Banner, our ERP. So for the folks that are using Banner, we're using every module of Banner. So it's our ERP, not just our student information system. And by bringing that in conjunction with the Blackboard data and the enrichment data, the publicly available information, what we are really excited to get into is really the student engagement piece with the artificial intelligence model. So I think starting with those two sources and the enrichment that we're doing, I think we're going to get to a point where we're going to start to generate some questions and some insights into how our students are engagement. What are some of the variables that correlate to an engaged student versus a not engaged student? And I think that's really going to help inform, what other data sources we should start pulling in to make further penetration. So I'm not sure if that helps or answers the question. Anything you would add there, Brendan?
No, I think that's good. We do have another questions come in. It's around data governance, and you and I have talked about one aspect of the design, which is to let data flow in the way it exists, so that if there's problems with the data, we can share where the problems are in the source systems with the teams that are responsible for either inputting or managing that data. But the question was specifically, above and beyond that, what approaches are you planning around your data governance, or are there specific tools that you'll be using to help manage your data governance process?
Yeah, another great question. So one of the other opportunities that we identified, in addition to the non-existence of a data warehouse, is that we really didn't have a data governance process here at PCOM. So one of the things we are doing is in parallel to the rolling out of the data warehouse and the build out of the data warehouse, we are slowly implementing a data governance process. And one of the tools that we're using is a product called the Data Cookbook. And the Data Cookbook is a tool that's going to allow us to do a couple things. It's going to allow us, as we build out the data warehouse, to really start defining those business terms and technical terms, that, probably get confused across the different departments. So the data governance allows us to put some workflow in place where we can define terms and get them approved by the owners of that data on the data governance team. And then that data becomes available. The functional definition becomes available to folks, and the technical definition becomes available to folks. I won't get too much into the data cookbook, but it's pretty interesting because the data cookbook also allows us to tie those definitions back to the source data system. So the metadata. So if you define, for example, an active employee, for example, within the data cookbook from a data governance perspective, we can tie that back to the specific data elements within Banner that represent an active employee and so forth. And the last thing I'll say about this, because I don't want to get too much into the data cookbook, is I mentioned earlier that as data flows, we're going to be concerned about quality on the way in. The data cookbook has a way for us to connect to Snowflake so that we can watch data that's flowing into those collections and flag any quality issues on the way in, so we can resolve that in a timely manner. So data governance is a big piece of what we're doing, and it's running directly in parallel with the data warehouse. equally as large an effort, but we're doing them at the same time.
And one of the things I could add to that is, in order to support the work that Rick and the PCOM team are doing, we've talked about the 3 data collections, which provide a lot of analytic capability, especially around the student and the academic domains. There's a 4th collection we provide, which is all of our data dictionaries. So for all of the data elements available in all those different collections, there's a dictionary element there, which the team can use to then connect into Data Cookbook and allow data to flow back and forth.
And there's one thing I'll add to that, Brendan. So as Brendan just mentioned, that the Invoke folks provide a definition for all those terms, but they also provide another element. They provide the lineage. So I can look at student ID. I can know that's I can see the definition for student ID, but then there's another column that they provide, which is what is the source system and what is the metadata that came from. So very easily we can trace that collection element all the way back to the source system, which has been very valuable for us from a data cookbook perspective, and also the data quality dashboards that we built in advance.
Perfect. And for everybody, I know we didn't get a chance to get to every question, but we are coming into our last minute here, and I want to make sure that we don't make anybody late for their next meetings. So please take advantage of the contact information that's up on the screen. If you do have questions, and we will actually share some information back to all of the attendees today in terms of the questions that were asked, so that we can distribute answers along to those as well. But feel free to reach out to either Rick or me if you would like to talk in more detail about any of the aspects of today's presentation, and we'd be happy to have that conversation with you. But Rick, thank you so much for today's presentation. I really appreciate just the depth that you went into, not only about your current experiences, but really the original approach.
Thank you. I appreciate the opportunity. And like I said, if anybody has any questions, feel free to reach out. I'd love to continue the conversation.
Thank you, everybody. We appreciate your attending today. Look out for future webinars that we'll be doing as we proceed. But thanks again. We hope you have a great day.